Today we're going to talk about protecting your sensitive data in the Oracle E-Business Suite. Again, my name is Steve Coase. I'm the Chief Technology Officer with Integrity. For those of you not familiar with Integrity, we basically bridge the gap between Oracle E-Business Suite databases and security. Our main goal in life is to help you protect your Oracle E-Business Suite environment from anyone out there trying to get in and hack it from both inside your organization and externally. Integrity basically does two different things. We do a lot of security assessments for our clients, so that's either on-site or remote, and we basically go through your environment with a fine-tooth comb, trying to find different security weaknesses and issues. And then we also have a product called App Sentry that helps automate the process, and it is a tool that we sell to our clients that can go through and basically do a scan on a periodic basis to make sure you're in compliance with some of the things we're talking about today and with some of the general security hardening for Oracle E-Business Suite. So that's enough about data intensity and integrity, and so let's start talking about protecting your sensitive data in the Oracle E-Business Suite. So looking through the registrations of today's webinar, we actually have a very mixed group. We've got everyone from internal audit to IT security to DBAs to a lot of consultants. And so what we're going to try to do is keep it at a high level for everyone at this point and kind of discuss in general some of the sensitive data in Oracle E-Business Suite environment and some of the different methods that you can use to protect it. So we'll start off with a little overview of sensitive data, what are we talking about in terms of data elements and where those might be stored. And then we'll talk about a few specific ways to help protect that data. And these are very broad and general, and we'll kind of go into some specifics, but also keep them as a higher level topic because each of these we could go through a couple-hour presentation on. So first we'll talk about some of the encryption options within Oracle E-Business Suite, some of the issues around data access and how to protect that, and then talk about auditing. And especially when you can't do encryption, auditing is a very good solution as a mitigating or compensating control. And then we'll kind of open it up for the last 10 or 15 minutes for questions and answers. So let's start off talking about sensitive data. And what do we mean by sensitive data? So there's a number of drivers for security and compliance in general. So mostly Sarbanes-Oxley, kind of in the webinar registration, we asked you what were your main drivers. Sarbanes-Oxley was overwhelming the #1 pick there. Although a number of people did pick payment card industry data security standard. And for those of you not familiar with PCI-DSS, the credit card brands Visa, MasterCard, Discover, American Express, and a few others got together and are pushing on to merchants, basically people accepting credit cards, a number of stringent security requirements. And we'll actually talk about that in more depth because one of the major requirements is encrypting credit card numbers. And we'll talk about that specifically in a few minutes. And then also privacy regulations. A number of people have talked about the state privacy regulations as a major driver for security compliance. And primarily California and Massachusetts have been the drivers of those in terms of data privacy laws. And we'll kind of talk about the specifics about what you need to protect and different ways you can protect it. So let's first start at a very high level and start talking about sensitive data. And what is it and where is it in Oracle E-Business Suite? When we talk about sensitive data, we're talking about a number of different elements. And here I'm breaking them out by pretty much what the privacy compliance requirements are. So PCI-DSS is a fairly big one for a lot of people because it's very specific what has to be protected and the way to protect it. And primarily there it's credit card number. And anyone who's been through a PCI audit, the PCI auditors really refer to it as primary account number or PAN. So if you've got someone running around your organization talking about PANs, it's basically primary account number, not a cooking utensil. The other number is a little confusing. Everyone knows what it is because you always actually have to pull it out. But the name probably isn't familiar to you or many people. It's CVV, CV2, or CID. And what that is the 3 digits on the back. So whenever you go to Amazon or an e-commerce website and you have to put in your credit card number, they ask you to flip it over and pull those 3 digits off above the signature line. For Amex, it's actually on the front. CVV can never be stored, or it can only be stored for a very short term if you're actually having a delay in processing credit card numbers. But you really shouldn't be storing that number. So that's a very critical element when you're looking through sensitive data, that you're actually not storing data that you're not supposed to be storing. Another one is magnetic stripe data. So when you swipe your credit card somewhere, the machine's reading off a bunch of data off the back of the card that includes your name and credit card number and some other pieces of information. That shouldn't be stored. Fortunately, Oracle Business Suite customers, there is no native way in the application to store that data unless you're doing it through a customization. Another area is the state privacy regulations. So when we're talking about that, primarily California and Massachusetts, again, are the key drivers, and I've actually pulled these requirements directly out of the Massachusetts law. So whenever you're storing any combination of first name and last name plus one significant number, so a significant number is defined by the law, is very clearly Social Security number, credit card number, bank account number, any type of financial account number. That one's a little confusing, not well defined, but if you're running an insurance company, a bank, or financial brokerage firm, those are all financial account numbers that can be used. And then the final one is driver's license number. So for privacy regulations, if you're storing that data and you lose that data and it's not encrypted, you actually then have to notify everyone who lives in those states that are covered by the privacy laws. And as of today, there's about 23 states that have some form of privacy laws, with Massachusetts and California kind of being the big ones. Vermont does a little bit, I think New Hampshire and other states. So the key elements there are one of those numbers in combination with your name, and if you lose that, you have to do a notification. So that's why the privacy laws are becoming so critical. And then finally, HIPAA. You would not think that Oracle Business Suite would be storing much health information, but actually there's a number of scenarios where it does. Primarily, the biggest companies that would be affected by this would be if you're a medical device manufacturer or someone that's actually producing and shipping something that is kind of medical oriented. So if you're a small medical device manufacturer shipping directly to the end customer, that's health information. And so if you've got someone's name and basically going through order management or accounts receivable and you're actually shipping out product, that's considered health information. Potentially also in HR, there may be health information stored. Most HR departments are pretty good about that, but we've actually seen some cases where they're actually storing medical records or different privacy-related information like psychiatric reports or something. Even a reference to that could be considered health information. Unfortunately, with HIPAA, the law is very vague, so it's very hard to know exactly what would be within the HIPAA regulations and not. So you do have to be careful about that one. So the next question is, where is actually the sensitive data stored? So those are the key elements. And most organizations don't get down to that level saying, okay, yes, it's bank account number, it's date of birth, it's first name, last name. What do we have to do with each of those elements? So if you go through your organization's data classification standard and it says, well, personally identifiable information, you really need to be looking at that standard and trying to update it because it helps down the food chain saying, well, someone maybe in the legal department or compliance department said, well, it's all PII data, personally identifiable information. Well, what is that? What elements are there? Is it date of birth? Is it first name, last name, address? What's actually included in there? And then there should be levels to say, well, these elements need to be encrypted. These elements need to have restricted access, those type of things. So after you've got a very good data classification standard, the key is then to figure out where is that data stored in the Oracle Business Suite. And that's really the first step in protecting is you have to know where it is. And so here's a list of different tables that actually store some of these values. So for credit card data, it can be stored in 10 or 12 different tables throughout the application. For Social Security number, well, HR is a very standard one. Well, in PRL, people F, you're storing national identifiers, the column that stores Social Security number, and also identifiers for Canadians and UK people and within Europe. Well, how about if you've got contractors that are doing 1099s? Well, their tax ID is also their Social Security number. So you might actually have some Social Security numbers in your AP suppliers table. And so this data kind of permeates throughout the application, and it's not easy to say, walking into when we do an assessment of a client in a sensitive data search, well, where is our sensitive data? Tell us the list of tables. Well, I really can't do that until I understand what you're using the application for, what modules you're using, what customizations you have. Bank account numbers are another one that tend to be scattered throughout the application because different modules use them. AP checks all is a pretty obvious one. Invoice payments is, but this information can also be stored in HR and other places. Protected health information, and again, what is your definition of that and how are you using the application? So it may be stored in order management, there may be certain cases in human resources. So one of the major challenges in protecting sensitive data is first finding out where it is in the application. Well, these are all the standard tables. How about every other place it might be in the application? Well, custom tables are mostly when we do our sensitive data searches for our clients. Custom tables are really where we find most often the data. Typically in the business suite, we get to a fairly short list of tables that are the standard tables by Oracle. But what happens is with customizations, Social Security numbers might be in 1 or 2 standard tables. They might be in 10 or 15 custom tables, because now you're maybe using HR as your system of record throughout your organization. A whole bunch of interfaces were developed 5 or 10 years ago before no one even thought about what Social Security numbers were and how you needed to protect them. And so that data might be getting passed through multiple interfaces back and forth in a number of custom tables. It's not uncommon for Social Security number to be in 4 or 5 custom tables if you're running a large HR system. Another one that we find occasionally, it's very difficult to find and know where it is, but flex fields. Flex fields can be defined to contain any value, and some people occasionally will store either a credit card number or a Social Security number in the flex field for some reason. There's always a valid business reason at the end of the day, but it's fairly difficult to find. And what we do is at Integrity is we actually have an application that we will be incorporating in our App Sentry tool in the future. But basically it goes through every row and table and kind of searches column by column, row by row, looking for pattern matching of Social Security numbers, credit card numbers to figure out where it might be stored in these unobvious places. Like a flex field, the column names are not credit card number. It's the standard flex field column names. Another area that we find quite often is in what we call maintenance tables. So it's a very common scenario for many organizations to do direct SQL updates. So maybe something's stuck in HR. So the all people F table has an error in maybe 3 or 4 rows. But the DBA has talked to Oracle, and Oracle has given them a SQL statement to go in and basically clean those records out or make a fix. And so basically it's a direct SQL update, which is very seldom done and only on the advice of Oracle typically. But it happens maybe 2 or 3 times a year. DBAs will do this. And the first thing every single DBA does, or every prudent DBA, I should say, and also your DBAs are also doing this, is before you do that update, you either take a full backup, which is probably excessive. But what they can do very easily is create a new table. The syntax is basically create table as select. And you can create a temporary table that is holding the table that you're going to do direct SQL update to just in case anything goes wrong. So they'll name it something like this, PR all people F, with maybe a date after it. We typically look for that as a pattern to find these a lot of times. And then what will happen is they'll go back to the application team and say, okay, let me know if that worked, and then we can move forward. We fix the problem, right? Well, does the DBA put on his to-do list to make sure he deletes that table that now has a full copy of all your Social Security numbers? Most likely not. And so that table just then ends up sitting out there. And you might be scrambling data when you're copying it to test and development, but, well, that table's not on the Scramble list, so your Social Security numbers are now unscrambled in your test and development environment. We find these quite often. Probably almost every assessment we do looking for sensitive data, we'll find at least one of these tables that has some amount of sensitive data that was meant to be temporary at the time, but basically lived on. Maybe lived on for 3 or 4 years. That's not uncommon to find these. Another area is interface tables. So credit card numbers, Social Security numbers are coming in and out of the application through either custom interface tables or even the standard Oracle tables for APIs. These should be really temporary tables, so things should be written into the table, processed, and then the records deleted out of the table. But that actually happens probably the majority of the time, but a lot of times records will get stuck in these tables. So we'll go through and do an assessment looking at the interface tables, and we might find 100 or 200 records with either credit card numbers or Social Security numbers in those tables. Well, 100 or 200 may not sound bad, but if you're trying to do identity theft, some of the industry benchmarks are maybe for identity theft, you can get someone's Social Security number, name, address, some good information. That's worth about $50. So that might be $5,000 or $10,000 worth of Social Security numbers just lying around, that if someone can find those that aren't protected as all your other tables are, if you're doing a good job, you've at least got a weakness there. Another area is interface files. So you're actually processing interfaces and batch processing. These flat files are flowing in and out. Well, most often those files are archived, so those might also have Social Security numbers, credit card numbers as they come in. You're just archiving them into a backup directory or something to keep them. So you've got, again, data just kind of scattered about. And then also log files. A classic example of log files is the iPayment application. until a year or two ago, it was very easy to actually generate a full log of everything that was getting processed. So this actually included both credit card number and the CVV code, which you should never be storing. A lot of times we find clients where actually still have the log debugging functionality on in night payment, and we're actually writing out a full log file with all the credit card details, including CVV numbers. So it's very common to have those type of log files. And so again, this is just a lot of searching, trying to figure out where the sensitive data might be in your environment. So no matter what else you're doing is, well, you think you've got a good hold of all the data elements where they are. Well, sensitive data tends to be scattered around, difficult to find, and it's kind of the last place you look is where someone finds it pretty quickly. So that's kind of an overview of sensitive data, what we're talking about when we mean sensitive data elements, kind of where it is, and framing the problem, because the problem is not that simple. It's just not, well, one single table, PR, all people F, I need to protect that. I can easily encrypt it, or I can audit that table. Well, those security numbers aren't just in that table. They're throughout the application. And so whenever you're devising a strategy to protect the data, you need to be thinking more about all these other places that it may be also, not just one or two tables. So one of the ways to actually protect the data is actually encryption. And so there's a number of scenarios here that you can use. And the key for encryption is there's several different types of encryption. The first is storage, so when it's actually data at rest. And so these are kind of standard security terms. And so storage encryption or data at rest is when the data is actually stored either on a disk drive, a backup tape, maybe a USB key. So basically, after I've written out the data, it's somehow encrypted when it's actually sitting on that. And the key here is for storage encryption, what I'm trying to protect against is if I lose a backup tape, if for some reason I lose a disk drive. There is a classic story about a couple years ago. Someone attacked a data center and they took their pickup truck, backed it up, and smashed a huge hole in the data center wall, ran in, and actually took part of a disk cluster and drove off. And no one's quite sure why they did that and kind of what the overall scenario was, but basically that's kind of a scenario that you could lose a disk drive. That's probably a rare circumstance, but those type of things happen, and that's what storage encryption is looking to protect. A little different idea is access encryption or data in use. So when we talk about some of the storage encryption technologies, those are only encrypting it when it's on disk, not when I'm accessing it. So if I have a database session and I'm actually querying something, if it's just stored encrypted, I most likely will see it unencrypted based on the different technologies. Access encryption is now allowing me to enforce the encryption maybe based on my login ID, responsibility, or something like that. And we'll actually talk about these two different types in a minute here as we go through some of the encryption options. Then finally, network encryption is when it's actually flying across the network, either your internal network or the internet. And so this is the classic one here is SSL. So when you talk to your bank and you type in HTTPS, that S stands for SSL, so it's actually being encrypted using certificates across the internet to hopefully protect the data. We're not going to talk about network encryption today at all, but that's just another type, and you need to be thinking about all these different points of where is the data encrypted, how can people potentially access, and where are my risk points. So when we're talking about Oracle E-Business Suite, there's a number of different encryption solutions that are possible. And it really depends on what you're trying to protect, how you're protecting it, and how much you want to spend. At the end of the day, a lot of these options are fairly expensive. So natively and inherent in the Oracle E-Business Suite, there's only one type of encryption that's basically free with the application, and that's with credit card numbers. So basically, in 2006, Oracle released a patch in 11i, and it's kind of standard functionality within R12 to actually encrypt credit card numbers, and I'll go through how this works in a few minutes. But basically, that's the only thing that you can get out of the E-Business Suite. So there is no native encryption of Social Security numbers or any other sensitive data within the application. The next technology directly supported by Oracle and fully supported by Oracle support, which is actually a fairly key piece of it, is Oracle Transparent Data Encryption. The key about Oracle Transparent Data Encryption is that it's only encrypting it at the disk level. So when the database reads and writes the data to and from disk, and also in the memory buffers, depending on version, it's actually encrypting it. So if you lose a tape drive, or a tape, or a disk drive, or someone goes in as a hacker and gets access to the operating system and steals your database files, the data is encrypted. But as soon as I sign on to the database and have a valid database session, the data is completely unencrypted. And the key here also is it's part of advanced security option. So this is an extra cost per CPU. And depending on your environment, it may be $50,000 to $250,000. Another option is basically custom encryption. So you can actually use some of the standard libraries that Oracle delivers. So DBMS crypto is what the Oracle database delivers for encryption. And so if you're writing customizations, it's actually fairly easy when you're writing the customization for the first time to actually include encryption, because the Oracle database provides some very nice encryption libraries. The Oracle E-Business Suite also has the FND Vault packages, which use the same, which are the encryption libraries used for the credit card encryption. That's basically the first option here, and those can also be leveraged. The API is undocumented though, but it does provide some very nice key management features. And then finally, there's a number of third-party encryption solutions available that either are writing to and from the disk. There's Metric and a few others for disk-level encryption, which is basically competitors directly to Oracle TDE. Or there's also another set of packages that are basically providing a set of views and triggers that then provide you a layer of encryption within the database. So depending on your responsibility or login, when you're actually accessing the data, it may be encrypted or not encrypted based on the way the view and the triggers work. These solutions most likely are not directly supported by Oracle, and you have to turn them off in order to troubleshoot some problems. That's one of the issues with any of the third-party encryption solutions is, well, Oracle support is not existent, and therefore you might have to go through some troubleshooting to actually get additional support from Oracle if there is a problem. So let's first talk about the Oracle credit card encryption. So basically, delivered with the application is a very nice encryption solution, which is also PCI compliant. So for those of you looking to encrypt credit card numbers stored in only the standard Oracle tables, the standard Oracle Business Suite credit card encryption works fairly well. You don't need TD or any other solutions, and it's actually included with the application, and it's supported in 11.5.10.2 and above. It's native in R12 installed, but it's not enabled. So one of the key points is, even if you install these patches or you have R12, the encryption is not enabled by default. You actually have to enable it. And what happens as part of the enabling process is, as we talked about before, credit card numbers are scattered throughout the Oracle applications, and they're stored by module today. If you are running 11i from upgraded over the years, you might be running both maybe Oracle Order Management, maybe Oracle Collections or AR. You'll have credit card numbers stored in multiple tables. And that came about because as those modules were being written, they said, well, we need to process credit card numbers in this module, and each module team just wrote their own. So Order Management said, well, how are we going to handle credit card numbers? And they wrote their own routines and did everything there and stored it in their own table. In order to improve the encryption process, Oracle actually goes through and now takes all those credit card numbers as part of the conversion routine from each table and actually moves it from the red table there into the green table, IBY security segments. So the one big advantage is you're now taking multiple tables that are storing credit card numbers and actually moving those credit card numbers into a single table, and then those values in that table are encrypted. So they've actually done a fairly good job about this, but it is a fairly significant change to the application and is not enabled by default. That's one of the keys. Even in R12, when you start using it, you actually have to enable it to allow this functionality. So that's saying credit card encryption. So if you're running PCI, definitely recommend installing that and start using that. So that's only for credit card numbers. So if you're talking about now protecting Social Security numbers, bank account numbers, or other values, there is no native solution in the application. There are enhancement requests open with Oracle. We'll see when those ever come about, because just to do the credit card encryption took Oracle 3 years and had to do a massive change. There was like 60 form changes, 80 reports. There's a massive amount of change. So I wouldn't be looking to Oracle to have Social Security number encryption anytime soon. Probably in Fusion applications it'll be available, but within 11i and R12, probably not anytime soon. So your other option then is Oracle Transparent Data Encryption. So again, this is a very limited set of functionality, and this may satisfy your requirements. This is one of those issues that you now have to talk to your legal department and your compliance team to decide, will transparent data encryption work for me? very nice feature about transparent data encryption is, well, it requires no application or code changes. There's nothing that changes. Basically, all it's doing is when the database is reading and writing the disk, now basically the data is being encrypted when it's being written out. So if you lose a tape, you lose a disk drive, you lose a database file, it's fully encrypted. But as soon as someone signs onto the database, they can fully see the data. There are a number of limitations, though, in TD. You can't encrypt certain columns if they're foreign keys. You can't encrypt like a date value. They have to be under a certain length. Every field we've tried that you'd really want to encrypt in Oracle e-business suite environment works. We haven't really run into anything that would be out of the ordinary. The only time we run into a problem is if you're trying to encrypt. There's sometimes XML records are being stored in the application, things like that. Those typically are too long to encrypt, but anytime you store a social security number, bank account number, there has never been a problem. So it does provide you some capability there. And the limitations more likely are going to be if you're trying to pick date of birth, some values that are a little bit more complicated like that. Or also in your customizations, because if you're doing your customizations correctly, you might actually have some foreign key relationships. But typically that would not happen like bank account number. Social security number is the only one that we've ever thought about where a foreign key relationship would be a problem, and TD wouldn't work for it. So again, TD is only encrypting it at rest. So once I sign on to the application or the database, it's not encrypted at all. So anyone authenticated that has access to that table can fully see the data. The key here is Oracle really claims, yeah, this satisfies all your privacy requirements, it satisfies PCI, satisfies the state legislation. You really need to talk to your legal department, because if you look at the California bill very closely, it says if these values are encrypted and someone steals it, therefore you don't have to do any sort of notification. The key is, how did someone steal the data now, TD? If someone basically, if you lose a tape drive or tape, your values are encrypted on the tape, therefore you wouldn't have to do a notification to anyone. However, if the hacker comes in and basically gains access to your database and queries the data in the database, the values would not be encrypted, therefore you would actually have to do a notification. So TD works, it doesn't have many problems with it, but it doesn't give you full protection. Oracle claims it does, but you have to be very careful to move around the sales and marketing pitch to what it really can do. A very nice feature that now that's been released in 11G, standard Oracle TD in 10G was only for columns. So basically you could pick one column at a time and encrypt it, and you could pick as many columns as you wanted, but you actually had to go column by column. And this is actually the recommended method for all standard Oracle Business Suite tables. So if you've got the PERL-PFF and you want to encrypt the social security numbers, that's the national identifier table. And so all you have to do is basically go in and do an alter table, and you actually turn on encryption for that column. One of the keys, though, is that SALT is not provided for Oracle Business Suite columns. And basically, for those of you not encryption gurus, what SALT is adding a second value. So if I encrypt a value with no SALT, and that value appears 2 or 3 times in a table, that value would be the same encrypted value. And this really just depends on how secure you want the encrypted value. For social security numbers, you shouldn't be repeating those in most of these tables, so really having SALT is not much of an issue. However, if you're doing credit card numbers, that could be a little bit more of an issue. One of the reasons Oracle doesn't allow SALT for e-business suite columns is for searching reasons. It's actually easier to search without SALT. Now supported for 11G is a second type of encryption. It's table space encryption. So prior it was only column encryption, so you just pick one column at a time to encrypt. Now you can actually encrypt the entire table space, so that's all the tables within that table space can be encrypted simultaneously. One of the problems here is that the way the Oracle e-business suite table space model works is there's very large table spaces, and it's very hard to encrypt a large table space without significant overhead. And so now what happens is I'm achieving a lot of overhead that I wasn't seeing in column encryption, and I'm encrypting a lot of data I don't need to. So the recommendation for table space encryption is never encrypt standard Oracle e-business suite tables, but selectively choose custom tables. And the reason we like to see the custom tables encrypted, especially with a large amount of customizations to an application, is that you don't know where the credit card numbers are. You don't know where the Social Security numbers typically are in those tables, or your development process isn't rigorous enough to say, one developer says, oh yeah, we're going to add credit card number to this table now. Is your process good enough to communicate that to the DBA so now that the DBA knows to turn on TD encryption just for that column? Probably not. We see it quite often that if we find unencrypted values in an Oracle Business Suite environment for someone who's using TD today, typically it's 99% of the time in a custom table. Very seldom is if they've done a good job on a standard table search that they've found them, they're doing a good job, but it's almost always in the customizations. So one way to ensure if you need a high level of reliability on encryption is to encrypt table spaces and pick a lot of your custom tables and use table space encryption there. One key aspect of table space encryption is when the data is in the SGA. The SGA is basically the buffer memory of the Oracle database. So when it's reading blocks from disk, it's storing them in memory just so it has quicker access. That for table space encryption, the data is not encrypted in the SGA. So there are some limitations on the table space encryption, but it's a very good solution for custom tables, especially when you don't know where values might be. One of the big concerns then with TD is, well, and also any type of encryption, is performance. How much will it actually impede my performance on an application? Especially if you're talking about Social Security numbers and you're talking about an HR payroll system that has to have a very good performance in doing large payroll runs. Well, column encryption from our benchmarks at a few customers is about 5 to 20%. Table space encryption has a much higher CPU performance for almost every scenario that we've ever seen because it's encrypting just a lot more data. And there's really not much of an impact on I/O. Sometimes if you're doing compression, you see a dramatic improvement. Encryption really isn't compressing the data at all, so you're not seeing any impact there. So you always have to remember, if you're at the edge on performance and your application is already dying, especially during like maybe large payroll runs or large batch processing, encryption will have an overhead. You need to account for that in your capacity planning. So there are a few scenarios where you see really poor performance, and so one of the problems that we run into is that we can't tell a customer where the problem is going to be. And so you really have to do some sort of functional testing, especially performance testing, to try to determine if encryption will actually have an impact. If you're running just a standard financial system with not a huge amount of volume, you'd probably never see an impact. If you're running a large HR payroll system and you're processing 250,000 employee records for a weekly payroll run, you will probably see some sort of issues occasionally. And the key is range scans are big ones. When you're joining encrypted columns, that becomes another problem. So some of the best practices that we've seen for TD is you have to be very careful. TD is now using the Oracle wallet. So the Oracle wallet is actually storing your encryption key, and you have to make sure you're not backing that up. That's a huge mistake we see many clients making, is they're backing up the encryption key with the database file. So if you lose the backup tape, well, the person who finds the backup tape has everything that they need. And you also need to protect the wallet. That's a fairly significant issue. So that's talking about TD at a high level. Now let's start talking about data access. So now we've potentially encrypted the data, but now there's some columns that you probably won't be able to encrypt. So how do you protect access to them? And for a lot of clients, they struggle with how do you actually get access to the database to a large number of people for read-only access. And so how everyone raised their hand who's got an apps read account or some other sort of standard Oracle database account that has fairly significant read access to the application. And typically what DBAs do is, well, I need to create this account, and based on the privileges in the Oracle database, it's hard just to say, well, you need access to these few tables or maybe just a few schemas. You can't grant access to the whole schema. You either grant access to everything or individual tables. When you've got an application with 40,000 tables, it's very difficult to manage those accounts. So there's always an apps read account with select any dictionary, select any table privileges, and so that account can access all the data. And so that's kind of the first thing to look at, is limiting access to that account. The second is you're now duplicating all the data in your test and development environments. Are you scrambling all Social Security numbers and credit card numbers in all locations? And the third is, well, there's just limited data encryption capabilities. You're probably not going to be able to encrypt everything that you want to, either just for cost, performance reasons, finding all the data. And then another area that we see a lot of problems with clients is, especially on PCI, Oracle Business Suite typically is data in for life. And so you load everything in there. Very few people purge or archive data on a regular basis. PCI compliance requires you to have the minimal amount of data available. So they only recommend 12 to 24 months, and I think the average is about 18 months, because after that you don't really need the credit card number. You may need it for some legal compliance, but anything related to the credit card companies, you don't need it. So we recommend you actually go through and either truncate or scramble the credit card numbers that are no longer used. You don't have to delete the transactions, because really it's a transaction you need, not the credit card number. So you can actually go through and scramble or purge out the credit card numbers but not the transactions, and you kind of achieve a much better security posture because you don't have that much data online. If someone's going to steal your credit card numbers, would you rather have them steal 5 years, or would you rather have them steal 18 months? It would be much better just to lose 18 months. So some of the major sensitive data access risks are really data seldom is scrambled when you're copying it from production. And this is kind of just one of those tasks that now has to be added as part of your clone to actually scramble the data. But the key is first finding out where is all the data. So is someone going through every 6 months or every year, making sure that you've added new custom tables, interface tables, those maintenance tables we talked about, and are you including that in your scrambling and making sure where those values are? And then again, sensitive data access by generic accounts. So now you've got these privileged accounts that can read all data, and you don't even know who's accessing them. So the key is now you start creating individual database accounts with roles that access to just a single set of data. And you can also use fine-grained access controls now to actually limit access to individual columns. That's one of the solutions we implement for many of our clients, saying, well, you don't really need access to a Social Security number. You need access to the PRL People F table, but do you really need access to the Social Security number as part of that table? And there's actually capabilities native for free within the Oracle database to limit access to certain columns within a table. And one of the keys also is for auditing and just control in general, there's a lot of generic and privileged accounts. So the DBAs have full access to all the sensitive data. They've got app, sys, and system, Apple sys. At the application level, how often are people passing around sysadmin account? Unless you've got a tightly controlled environment, these accounts might be shared by a number of individuals. If you're looking at PCI compliance in particular, the word trust is not in PCI. There is no word trust. You don't trust the DBAs. So you have to come up with competency and controls for, well, they have full access to everything. So I have to put in some sort of competency and control to understand what my DBAs are doing on a regular basis, because they have to use these generic accounts. The Oracle applications was not designed to allow a real granular set of controls, especially over the DBAs and those type of people. Remember, this application was designed in 1985, and the security controls just aren't there. You can't use the name DBA account to access the application to do standard maintenance activities. So one of the areas that is difficult for many of our clients is actually scrambling data, because the key process is you have to first identify the data locations, and you have to do it on a periodic basis to know where new locations are. One of the fortunate things with the e-business suite is we haven't found many situations where there's a lot of dependency within the application. So when you're actually cloning production down to test and development, there typically is not a requirement that's real. A lot of functional teams will say, oh yeah, we have to have that. But very seldom do you have to have the scrambling good enough to say, well, if I'm scrambling the last name in 10 different places, that name has to be consistent in every place. Very seldom in the e-business suite does that exist. And so scrambling becomes much easier that you don't have to maintain dependencies across tables. We've never seen anything that breaks the application if you don't maintain the dependency. It may be a little confusing occasionally, but for the functional teams will jump up and down and scream that you need to do it. We haven't run into any realistic situations where that's necessary. And then the other key about data scrambling rules, one of the things that we like to do for our clients is when we do data scrambling, is we set like the Social Security number to starting with a 7. For those of you who are historians of Social Security numbers and the numbering scheme, the numbers actually start out by region. So if you tell me your Social Security number, at least the first 2 digits, I can actually tell you where you're probably born. Well, the 7, it wasn't assigned. It was actually assigned just for railroad workers. So it's a very good number because it's a valid Social Security number that's very seldom used. And then you know if you go to any environment and someone sees a Social Security number that doesn't start with a 7, they know that number wasn't scrambled. And so that's actually a very easy way. We set this up, and it actually is self-protecting, because what happens is people will go through and all of a sudden someone testing will say, hey, there's Social Security numbers in this environment that don't have 7s. What's going on here? And if everyone understands that rule, well, what happened was maybe someone ran an interface with live data into a test environment, and you got in 10,000 new Social Security numbers with real live Social Security numbers. And so it's kind of a nice, when you set up your rules, to add in little tricks like that people understand, that you can actually have a self-policing data scrambling. Because a lot of times we see live data is moved in. One of the other problems in large environments is when you're performing the scrambling during the cloning process, it requires additional downtime. It's not unheard of to have some of the scrambles run for 5 or 6 hours during a standard clone process if you've got a lot of data that has to be scrambled. Occasionally we'll work with databases that have like 15 billion rows of data for large retailers and things, and there the scrambling process can take 12 to 24 hours for that amount of data. If you've got a large HR environment, it may take 4 or 5 hours just to scramble Social Security numbers. And there's some tricks that you can do by turning off archive logs and turning off some other features and increasing SGA sizes and things like that when you're doing a clone to actually cut down the scrambling time dramatically. Then the key for scrambling is there's a number of different ways to do it. Our recommendation typically is just use a simple SQL script. It's the cheapest, it's the easiest, the DBAs typically understand it. There are a number of third-party products, both from Oracle and other vendors, that actually try to automate a lot of this process. But one of the keys is the challenge is still always finding the data and then trying to set up the rules within those products. If you've got specific requirements that say, well, the last name has to be equal in every different table, and we have to spend a lot of time, you actually then need to buy either Oracle's data masking product or a third-party product. That comes with the application management pack that's part of the e-business suite, whether it's an extra add-on, is a data scrambling routine that runs standard as part of the clone, but that doesn't do any of the dependencies, so that's got a lot of limitations. So you have to spend a little bit of time to figure out what's the best way to actually do the scrambling, because there are a number of different options. So that's kind of scrambling at a high level, kind of talking about data access. If you do have more advanced requirements in terms of data protection, especially with the DBAs, there is Database Vault. So again, Database Vault's an add-on from Oracle. It works fairly well. It allows you to do fairly rigorous rules about how to actually allow access to different parts of the database and how you can actually segregate duties. If you're running a custom application, not the Oracle Business Suite, and you're designing it from scratch and you have a lot of very stringent security requirements, Database Vault works fabulously. It's expensive, it's somewhat difficult to set up, but it provides you a tremendous amount of protection. The problem, though, is with the Oracle Business Suite, it wasn't designed initially for Database Vault, so there are a significant amount of limitations. And Database Vault works fabulously for eBusiness Suite if you're running other applications. So the scenario would be is you're doing either server or database consolidation, and you've got 4 or 5 applications that you've moved into the standard Oracle eBusiness Suite database, so they're all running simultaneously in a single environment. This is kind of the Kool-Aid from Oracle about database consolidation. Let's consolidate everything onto one large X data box, spend a few $1 million there. Database Vault can provide you a lot of value there, especially if you have multiple DBAs handling each of those applications and you want to segment out there. But the problem with just native Oracle Business Suite is that there's all these generic accounts, and the DBAs need access to those accounts. So really, Database Vault doesn't provide you a significant amount of protection for the DBAs. It does if you've got a bunch of other non-application accounts accessing it, but it's very limited protection just for the DBAs. So that's database vault at a high level. We see some implementations of database vault, but not a lot, just because of limitations and the expense and the difficulty in managing it. So now, if you haven't been able to encrypt your data, database vault and other products aren't working for you from a database access perspective, you really then have to fall back to auditing. So I'll go through this part very quickly. So auditing does provide another layer of protection and really at the last resort, especially if you can't do other things. And if you have a reliable audit trail, you're using it to mitigate risk. Although, now talking about auditing within the Oracle database, there is a lot of limitations to the auditing. And most often we see clients wanting to audit when they have to protect against DBAs. So they're either getting something at a high level, saying, well, we don't trust the DBAs, or the DBAs are for some reason bad, or they're at an outsourcer, or they're living in India or something like that. And so we have to provide some protection. The native database audit trail is very powerful, but the one person that can actually manipulate it, access it, is the DBA. The only option that provides the most protection is actually syslog. So you can actually take the Oracle native database audit trail and actually write it out to syslog, which is the Unix logging system. And so most likely the DBA doesn't have root access in the box, so you can actually write out audit trail records out through syslog, which then would go to some external system for protection. The DBA can disable the audit trail, but once these syslog records are written out, they actually can't access them. So it provides a fairly robust protection. The DBAs can still turn off the auditing at will. You can hopefully include audit records that's saying, well, if I'm not seeing audit records for a while, alert me, those type of things. So for a free option, that's actually fairly powerful when you're using syslog. Whenever you're writing to the standard Oracle audit trail in the database, the DBAs can manipulate it very easily. So you're really kind of stuck then with an external audit solution. There are a number of good ones on the market, but again, it's a fairly expensive proposition to implement some sort of solution. Oracle's got their audit vault. There's products like Imperva and Guardium in the market that provide very good solutions and also have native support for the Oracle Business Suite. So that's from a high level perspective. Just kind of wanted to give a good overview of sensitive data in the Oracle Business Suite and kind of go through some of the options. Again, each of these topics you could spend a several-hour webinar on, just delving into one by one, going through encryption and data access, what you should do about auditing. But the purpose of this webinar was more to give you a high-level overview of these different options and kind of go through and say, what do we need to do and what are some of the paths that we should go down. So now we'll open up for questions and answer. I'll actually turn it back to Mike real quick here to talk about what data intensity is doing at Collaborate.
Well, thank you, Steve. And please stop by and see us at Collaborate there. We're going to be at booth 1313, and the marketing people assure me that we're going to have multiple giveaways as far as a MacBook Air, a few iPads, and some shuffles and iTouches. And very much besides that, would more than enjoy the opportunity to continue such conversations. Steve, I did have one question from somebody sitting alongside me here as far as could they buy a Scramble SQL script off of Integrity?
In terms of a prepackaged Scramble script, we go through each customer and kind of custom design it because it just depends on what you want to do, which tables you want to do. Unfortunately, there is no universal set of tables that you're going to want to scramble. That it's very unique to each customer what you want to put in each value. So we kind of have a framework and a shell we use, but then we can work with you doing the sensitive data search, figure out what columns you want to scramble, kind of what methodology you want to use, and kind of put it together for you.
Okay. And if someone was interested, I would assume they could either contact you or contact us, and we'd be happy to take it a step further with you.
Yes, definitely. So for those on the webinar, here's my contact information. Always feel free to contact us whenever you want. Anytime you have any questions, it really helps us fine-tune our message and kind of what we're doing in terms of our research and development. We like to answer clients' questions and prospective clients' questions. And if you have those questions, please send them to info@integrity.com. Also, we have a blog, and go to our website. We publish out all our information out on our website. So every quarter for the critical patch updates, we actually publish a fairly detailed analysis, information that you can't even find from Oracle in terms of what vulnerabilities are fixed. All our white papers and presentations like this are actually on our website too. And then also at Collaborate, we'll be giving 5 different presentations. Again, this discussion here will be given again, but we'll also be talking about real-life database security mistakes and real-life Oracle Business Suite security mistakes. We'll be talking about PCI and the Oracle database in much more detail also. So if you're going to Collaborate, we'd definitely like to talk to you and have you attend one of our presentations.
Steve and Mike, before we close it out, this is Phil Ryman with Integrity. I got a couple other questions here that have come from the various listeners. Steve, the first one is, what are the tools or solutions available in the market that also support the auditing of heterogeneous apps or databases?
There's a number of very good products. Unfortunately, they're fairly expensive. We worked extensively with products from Imperva and Guardium that provide very good support for multiple different databases. They'll support Oracle, SQL Server, DB2, Sybase, MySQL. And those products also typically have good support for Oracle Business Suite, SAP, and PeopleSoft. So one of the things that those products can do is actually when you log into the Oracle e-Business Suite application, and then that account's actually generating SQL statements at the back end that can capture that information. The one issue with most audit trails, though, that we always run into is, remember, all these audit trails are capturing basically SQL statements or SQL events at the back end of the database. That's not telling you that somebody performed a update vendor. What it's telling you is somebody actually went into the PO vendor address all table and actually did an update to vendor ID equals 1000, and they set column flex field 3 to some new value. And so it's actually fairly difficult for those tools to be used by internal audit and things. So it takes a fairly rigorous setup and a lot of time to actually make those work, fine-tune them in your environment, and kind of get out the value that you're looking for them.
Okay. Another one here, without getting too technical, Steve, could you explain how the encryption keys are protected? You talked about encryption.
Yeah. Depending on which solution you're using, the Oracle credit card encryption is actually storing the encryption keys in the application tables in 11i. In R12, they're actually using the Oracle Wallet. Oracle TDE also uses the Oracle Wallet. One of the issues with the Oracle Wallet is when you're starting up the database, you actually either have to provide the encryption key or do something else to get the encryption key in. One of the weak points today with most of the encryption solutions is you probably say the encryption keys aren't that well protected, and so you can actually find ways around or get the encryption keys if you're very diligent. If you're a hacker and you get full control of a server, there's a good shot that you could get the encryption keys because they're just not that well protected. Oracle TDE does have some capabilities to talk to hardware encryption solutions, those type of things. Those are fairly difficult to set up and make work correctly, and then you have another external dependency. So from a high level, protecting the encryption keys is difficult. And then also if you're doing pure PCI, PCI does have stringent requirements on how you do key management, key rotation, those type of things. And so you have to very carefully look at that. The Oracle credit card encryption is probably the bare minimum, but not much more at all. There is no dual knowledge required of keys, which was removed as part of the PCI standards, but it's not where it should be. And so at least it provides you some level of protection. Is it fail-safe? Absolutely not. And you just always have to keep that in mind.
Steve, I mean, how would you, next question, how would you compare the data encryption with data masking? I mean, which is better, access, performance, etc.?
So there's, as I understand the question, there's kind of two aspects. One is encryption. So basically, I'm encrypting the values, and depending on how that's working, if it's in the application, like the Oracle PCI credit card encryption, unless I have the correct responsibility, when I read the value, I'm reading an encrypted value, and then Oracle actually exits out on the screen. Well, data masking within the application will then maybe display just the last 4 characters. Fundamentally, is what are you trying to protect against is a key question. So if I'm masking the value on the screen, I can do that typically within the application. Oracle's gotten a lot better on the e-business suite at doing that. But that provides me no value if someone actually has a direct database session and they're going in and maybe doing the app's read account and they're accessing the data by directly querying the table. And that's where encryption can provide some additional value, especially if it's a database level encryption versus like TD. Also, not to confuse any of this with the Oracle Data Masking Pack. The Data Masking Pack is actually a misnomer because it's actually meant for when you're cloning a database and then you're trying to scramble the data. Data masking doesn't provide any capability to mask within the application. There are some third-party products. There's a product called ActiveBase that is a masking product that actually acts as a proxy for the database. And what it does is when you execute a query statement, it intercepts that query statement, and when it sees the data returned, it will actually then replace the values returned in the SQL statement and then display it to the application. Somewhat transparent again. So there's lots of different options. Also for PCI compliance, only R12.1 is truly PCI compliance from a data masking perspective. So there are lots of areas within 11i and R12.0 that you'll actually see credit card numbers when you're not supposed to see them, and there's not good enough application controls around those. So it kind of gets to the point where what are you trying to protect against? Where do you want to protect it? Where encryption is probably the most robust, but it's also the most time-consuming, expensive solution. Where data masking may be just what you need, and you can also do that via personalizations. We've seen that for one client put in extensive personalizations to every mask Social Security number every time it was displayed. And that's very doable within the e-business suite too. So I kind of gave a bunch of different solutions there. So it's really just, at the end of the day, it depends what you're looking to do.
And the last one here, I don't know, they could be asking you to be a lawyer. I'm not sure, but the question is, California regs seem to let you out of the loop if you encrypt, but what about if your access controls are weak?
So this is also an issue with PCI. A lot of these things are not determined until you actually have a breach. So you always have to keep that in mind. So the California regulation says you need to encrypt, and then PCI also says you need to encrypt, you need to do all these things. And you also need to be fully PCI compliant. The key for both of these are they're not truly assessed until you have a breach. So even though you may be PCI compliant, you've actually had somebody who come in and say, yep, I anoint these people, they're PCI compliant. Well, if you have a breach in either case, and the lawyers get involved, and everyone gets involved, what will happen is there will be a forensic investigation. And at the time of that forensic investigation is truly when you're being determined if you're compliant or not, and what was the state of the data. So for PCI, if there's a credit card breach, there'll be a forensic investigation, and only at that point will they assess if you are truly PCI compliant. So again, it's how you lost the data. So if you lost the backup tape, and it was encrypted, and you can prove it was encrypted on the backup tape, I think that holds up very well in court. However, if you're saying the data is encrypted and someone went in and was able to query the entire table and you're using TD, and they queried the table and it wasn't encrypted, that's not going to hold up in court very well. And so if you didn't do a breach notification at that point and you get sued, basically I think you're going to very clearly lose that lawsuit. Even though you're saying, well, it was encrypted, our legal department said it was encrypted. Well, someone accessed the data unencrypted, and they were able to do it very easily. So it's kind of one of those at the end of the day, you always have to think about what will stand up in court, and how was the data actually accessed? Was it encrypted or not? And there's different, based on the solutions, it may be encrypted or it may not be encrypted. And also, again, if one of your HR people go in and start querying 1,000 records one by one, well, they might have perfect access to it, and they basically were able to see it unencrypted, write all those credit card numbers down or Social Security numbers down, and go do something bad with that information. Again, it was unencrypted when they accessed it, and so therefore you'd have to do a notification. So it kind of now gets into the whole compliance is what holds up in court at the end of the day is really the major issue.